Alright, for this last question in 13.2, we're asked to find an exponential function of the form a times b to the x power that passes through the given points. So in part A, my points are 0, 3, and 1, 4.5. And so my function is going to look like f of x equals a times b to the x. And so if I look at what this first point is going to say about a and b, well, if I plug in 3 for y, then I'm going to get a times b to the x, and x is 0. But now b to the 0 is 1, and so I'm going to just get that 3 is equal to a. Alright, so that's nice. And let's just make a note here. This point is really our y-intercept. And as we saw in the last video, the y-intercept is really just the a value, right? That's the initial value of our exponential function. All right, what about the second point? What does this say? Well, if I set y to 4.5, then I'm going to get my a, which is 3, times the b value raised to the x, and x is 1, so I get 4.5 is equal to 3 times b to the first. B to the first is just b, so this is really saying 4.5 is equal to 3b, and now dividing, I'll get that b is 4.5 divided by 3, and that is equal to 1.5. Alright, so now let's just go ahead and put that all together. Our exponential function then would be f of x equals 3, my initial value, times 1.5 for the base raised to the x. Alright. Now for part B, apologize for this, I somehow lost my second point. That should be 1, 1.55. For whatever reason it disappeared on me. Okay, but we'll go ahead and just approach this in much the same way. We have f of x is a times b to the x. And now for this first point, this is saying, well, when y is 3.1, I'm going to have a times b to the x, and that's 7. Alright, so now unlike what we saw in part A, I can't actually take this any further as it stands on its own, because I don't know what b to the 7th is, whereas here I knew that b to the 0 is equal to 1, regardless of the value of b. But here, right, I'm basically stuck. But I do have this other point to work with, so let's go ahead and plug in its coordinates. I'm going to get 1.55, that's going to equal a times b to the first. So again, on its own, right, I can't say what a is or what b is, but now I have two equations with two unknowns, and so I can actually use those equations to solve for a and b, and I think the easiest way to do that is to set up the following proportion. The idea is, well, just take what I see from that first equation, 3.1, and then a times b to the 7th over here. So the first equation is playing the role of the numerators there on each side. And then for the second equation, I'm going to put the 1.55 there, and the a times b to the first, and that's just b, so I'll write it as just a times b. So I have this proportion, and notice the a's here will divide out, which is quite nice. And the b to the 7th over b, this simplifies to b to the subtract exponent, so that'd be b to the 6th. And then furthermore, 3.1 divided by 1.55, that's equal to 2. So putting that all together, now I have b to the 6th is equal to 2. So now to get b alone, I want to undo this raising to the 6th power. So to undo that, we go ahead and take a 6th root, or equivalently raise both sides to the 1/6 power. So here our b value is the 6th root of 2 which is the same thing as just 2 to the 1/6 power. If you go ahead and use your calculator, you get about 1.1225, roughly. Okay, so that gives us the base b, which is nice. We still need our initial value a, and I could now plug in this b value into either the first or the second equation. And since in the second equation I just have b to the first power, I'm going to go ahead and use that equation to find, oops, sorry, not b. I'm going to use that to find my a. And so let's see, I have 1.55. That's going to equal our unknown a times b, which is our 1.1225. All right, so then dividing, we'll get that a is 1.55 divided by the 1.1225, and that comes out to be about 1.3808. Great. All right, so now we go ahead and put that all together, and we're going to be done. F of x would be our initial value a, so 1.3808 times the base, which is 1.1225 raised to the x power. Okay, a little bit more involved, but same concept. All right, that's going to do it for this section. Thanks.